Hey everybody, have a look at your handout. This is exercises 18C, 18D. Basically what we're doing is just using a calculator. It's all tech active, solving questions involving normal distribution. Have a look at the first question where it says, suppose Z is a standard normal random variable. So what that means for us is this is the standard normal curve. So it has a mean of 0, has a standard deviation of 1, and this is that curve that we've sketched before in our CAS along the lines of 1 over root 2 pi e to the power of negative x squared on 2. But we're not too concerned with that formula, but what we need to do is, it says, for this normal distribution, show C where the probability that Z is less or equal to C is equal to 0.975. So there's going to be some C value where 97.5% of the data lies below, to the left of the C value. Now this part A is tech free. So what we're going to know is that we're thinking back to our 68, 95, 99.7. And so if we need 97.5% of the data to be below our C value, then what we're talking about is we're talking about 2 standard deviations. Because here would be 97.5% of the data. Because we know for 2 standard deviations, there will be 2.5% of the data above 2 standard deviations. 95% between negative 2 and 2, 2.5% to the left of negative 2. So we need to find the value of C by hand. We know that probably Z is less than or equal to 2 is equal to 0.975, so C equals 2. But here it says use your calculator. And so there's a couple of ways we can do this. One is we'll use the normal CDF command. So if I go to probability and distributions in normal CDF, what we're interested in seeing is that from negative infinity to my C value, the area is going to be 0.975. Now it's a standard normal curve, so the mean is 0 and the standard deviation is 1. And I need to solve this for where this area will be equal to 0.975. And I'm going to say, tell me what C is. We're expecting 2. C is 1.95996. 4 decimal places. C is 1.9600. Now, alternatively, in doing this whole nested solve norm CDF, the quicker way is to use the inverse norm command. It's off probability. It's off the same menus, but it's option 3 here, inverse normal. And for inverse normal, I can just say that the error I want is 0.975. Standard normal, so mean is 0, standard deviation is 1. Get the same answer. So basically, this inverse norm is just taking care of this whole solve norm CDF nesting, and it's a lot quicker. And so you might say, well, how come by hand we get 2, but by CAS we get 1.96? It's because when we're doing the 68, 95, 99.7, it is an approximation. And in the Tech Free exam, that's what you're going to use. But in the Tech Active, when you have access to the CAS and it can be more accurate, you're going to use your CAS. Moving on to the second example, this one's relatively straightforward. X is a normal random variable, so it's not standard normal, it's just a normal random variable. We're dealing with the raw data here. The mean's 100, the standard deviation is 6. So for DP, find the probability that X is less than 110. We're just going to get familiar here with using, again, more of our norm CDF command. Norm CDF, probability distributions. Okay, so we're saying less than 110. So we're going from negative infinity to 110. Now the mean is 100 and standard deviation is 6 because this is the raw data. And so this probability to 4dp is going to be 0.9522. Less than 105. Same form. Instead of going to the form, I'm just going to change it here. 105. 0.7977. Greater than 110. Instead of going to form, I'm just going to do it here. So this is from 110 to infinity. 0.0478. And finally between 105 and 110. (105 to 110), 0.1545. So that second example is quite straightforward, and this third example is going to be also quite straightforward. It says that the results of a mathematics exam are normally distributed. Mean is 50, standard deviation is 7. To 4dp, find the probability that a randomly chosen student has a score greater than 60. Now, as I'm going through this kind of problem, I can see that 60 is already more than one standard deviation above 50. So I'm expecting something well over 50%, and in fact, sorry, I'm expecting something well under 50%, and even more so towards a smaller number than that. It's still going to be norm CDF. I'm going to go at the form this time, just because I'm changing some of my values. So I'm going from 60 to infinity. The mean is 50 with a standard deviation of 7. 0.076 6. Less than 75. Same form. So we're going from negative infinity to 75. I think that's pretty likely. Yep. Less than 75, 0.9998, almost 100%. And just the last one now. Find the probability that the top 15% of the class, well, they're going to award the top 15% of people a distinction. What score do you need to get a distinction? When they're telling us top 15% of the class, that tells me that 85% of the class will be below. And so that's an error they've given us there. They've given us an error of 0.85. When I'm dealing with error, I'm thinking inverse norm. Inverse normal. So the area is going to be 0.85. That's to the left of the point that I'm concerned with. My mean is 50 and the standard deviation is 7. So the score you need is 57.255 0 for DP. And so really C and D of chapter 18 is about using your norm CDF and your inverse norm commands. Take a look at these two VCAR questions down here. I'll let you know that the answers for the first one is D and the second one is A, but make sure you're able to use your CAS to solve that. And then following that, have a look at the questions on the layout from exercises 18C and 18D. Of course, when you're done, you've checked all your work, let me know and I'll give you all the revision. Okay, have a good day.